faster. So now you continue. So let's say I'm plotting, I'm doing a reactions. I'll send here.
Yeah.
Okay. So zinc and HCl. So you know it produces gas and salt, right? It produces gas and salt, right? So to measure the rate, I can collect two, right? The first one, I can observe the change of mass of zinc divided by time. Or I can take the volume of hydrogen gas produced and I divide it by time. So still remember limiting reactants? Limited. Understand when I say limited addition? Like as students that always fail at the exam, that can limited. Rare, never pass and take the test 10 times, fail 10 times. So if I say limited means like it will finish at the end of the reactions, right? So now let's say I plot a graph volume of H2 produced centimeter cube against time.
Sir, shouldn't the line be curved because the surface area decreases over time? Rate of reaction.
This one I'm gonna discuss. Okay, so wait first. Yeah. So now let's say this is number 1 and this is number 2. Which one is faster in your opinion?
1.
Number 1.
Those who answer, yeah, means you understand it. So you not answer, I consider you understand already. So reaction 1 is faster than reaction 2. Okay, but I want you to pay attention at the end product. They have the same hydrogen gas producer. The hydrogen volume doesn't change, is it? So how can you make the reaction faster, but then the end product doesn't change? It means that here, the limiting reactants, the mole, the amount of mole stays the same. You don't change the amount of mole. So maybe you change the surface area and the stuff, but then you don't change the amount of mole. That's why the end product will be the same. Understand? So meaning if I write the equations, so when I have the zinc plus the HCl, it will become like zinc Cl2 plus H2, right? So let's say the concentration of HCl, I'm using 1 mole per dm cube. Then at first the volume is, let's say I use 20 centimeter cube. Then the second experiment, I also use 1 mole per dm cube. And the volume is also 20 centimeter cube. So I don't change the AZ, but then what I do is, at first, right, this is larger, the size is larger. Now, the second experiment, the size of zinc becomes smaller, but then the mass is the same. Larger size here. This one is smaller size, but then the mass of the zinc stays the same. So if you repeat this experiment, is there any amount of mole of the reactants that we changed here? No, I don't change any of the mole. But what I did is I make the zinc into a smaller size, so means they have more area in contact. if having a greater area in contact, it means the rate of reaction will increase. That's why it becomes faster. So do you understand until here? But then because the mole you don't change, that's why the end product have to be the same. Any question you want to ask until here? No, you can take a picture of the board first.
We have your amazing video, what for?
Sorry?
We have your amazing YouTube channel to look at. What for we take photo?
In case later you want to practice thoroughly, you need this. Okay, so now I clear the board already.
Yeah.
Now let's say if the experiment is zinc plus HCl, and then the zinc is in excess here, excess zinc. And now let's say I make the size of the zinc stays the same for both experiment. So experiment 1, I use 1 mole per dm cube, and I take 20 centimeter cube of HCl. Experiment 2, I change the concentration to 0.5 mole per dm cube, and the volume that I use is only 10 centimeter cube of HCl. So which one has a high concentration of acid? So means in the first reaction, the concentration of acid is higher. Where's the definition of acid? So they have more amount of what? H positive ions, right? So means the frequency of collision between the zinc and the H positive ions also will be more, right? So means that here I can say the rate of reaction. But then the problem not only that, another thing that you have to pay attention is you use excess zinc. So who is your limiting reactants in this case? The acid. What is the mole in the first reaction? How much is the mole of acid in the first reaction? 0.02 times 1, so it's 0.02 mole. How much is the mole of acid at the second experiment? Let's say the volume is 20 here. I have a typo. So let's say it's 20. So it will be 0.01 molar. Let me fix this. This one is at the first experiment. This one just now have to be 20. So same volume, but then I just change the concentrations. So means the mole is 0.02 mole, and the second experiment is 0.01 mole. Anyone want to ask questions until here? So when you write the chemical equations just now, you have zinc plus HCl, right? Becomes zinc Cl2 plus H2, isn't it? So if your HCl is 0.02 mole, then your H2 here will be 0.02 mole. So if your HCl is 0.01 mole, I mean this one is 0.01, half of it, because so when it's 0.02, this one will be 0.01 because only one unit. So if the HCl is 0.01, it means the H2 will be 0.005. The equation is until here. comparing the ratio of the coefficient to find the mole. Understand? So means when I draw the graph, it's no longer the same with the first slide just now. So when I draw the graph, between my first and the second experiment, the first experiment definitely have to be steeper because it's
How do you get
faster.
0.005?
Half of the mole of the HCl. Right? Your second experiment, so will they have the same end product in this case? Your volume of H2 collected, can it be the same?
No.
It won't be the same because you have different amount of mole in the limiting reactants. Any questions until here? So when you solve the rate of reaction problem, when you are drawing graph, when you are reading graph, it can be a lot of model. So if you change the limiting reactants, the end point will not be the same. If you don't change the limiting reactants, the end point will still be the same. Want to take a picture of this?